Hi, today we are going to use a pre-trained model based on a transformer in order to run image classification on your custom dataset. So basically we will learn how to take this model and adjust it to our needs, use a custom dataset and do all the training, and after that of course we will test some random images on our custom-made model. So let's run a short demo to explain what we are going to do in this tutorial. So this will be our dataset. As you can see, it's named as 5 vehicles for classification, and if I open one of the categories, one of these 5 categories, you can see that there are images. This is, for example, an images of a buses, and these are images of a train. And we have here more than 6,000 different images. As you can see, we have a validation folder and a test folder. And basically we will use a transformer in order to do a fine-tuning to this model and adjust it to our custom dataset. And after that we will run this prediction or test Python code. So let's run it and see the demo. What I'm doing now is grabbing 6 random images from the test folder and comparing the true label with the predicted label. So we are running prediction on the fly and compare everything. As you can see, these are the 6 random images. For example, this is an image of a train. You can see the true value is train, and also the prediction value is the same as well in this image, and for this bus image as well, and also for these 2 buses. This one, I can see there is a difference. You couldn't choose the right class. I believe that if a human will watch this image, it's hard to see if it's a train or a bus. Maybe because of the speed it seems like a train, but of course it can also be a bus. Let's try another run. So I will run it again. Once again it will pick 6 different random test images and run the prediction on the fly and display the compare between those classes. Now, as you can see, here is the true value, it's a bus, and also the predicted value is a bus. This one bus as well. This one is a truck. You can see the predicted value and the true value are the same. Once again, here the bus, here for a car, and here for a train. So as you can see, our model is comparing very good. I can also mention that the process was very fast, about 15 minutes of training. So this tutorial will be a step-by-step, and I'll explain how to create this classification based on transformers. So let's start. So let's start with the installation part. This will be our installation guide. I will leave a link for the code and for the installation file named installed.txt. So here's the file. I will do a short brief for the content of this file. So first of all, we are creating a new Anaconda environment. I'm using Anaconda here in my local computer. So conda create -n, n is the name, choosing a name. The name will be ViT, which is Vision Transformers, and you can choose your custom name, and as you can see it will be based on Python 3.11. So this command will create the environment, and the second command will activate this environment, this new environment, and it will become our current environment. Then we are installing a PyTorch. When you are installing PyTorch, you should know what is your CUDA version, and the CUDA version is based on the installation of your GPU card. So if you go to the PyTorch website, you can find all the versions of the PyTorch. I decided to install 2.5.0, with CUDA 12.4. So first of all, you should run locally this command nvcc ---- version, and you will discover what is your CUDA version. And after that, you should go to the PyTorch website and look for this version 2.5.0, and you can find several installation commands for a different CUDA version. As you can see, I decided to install the 12.4, which is suitable for my local machine. You can also find the command for installing it on a CPU card, and for if you don't have a GPU card on your local machine. Then you should install several libraries. First of all, you should install the SumPy with this specific version. It's very important. Then you should install the transformers. I'm using this version. If you'd like to get the same results, please choose the same versions. So these two both commands will install the transformers with a focus on the PyTorch. If you get any errors like this one, you can also run that command, which will install the last version. But I prefer, if you would like to get the same results, please use the same version. And after that, there are several Python libraries like OpenCV to deal with images, and more Python libraries that are relevant for this and for more visual transformers tutorials and projects. So let's continue to the coding part. Great. Next step will be discovering and downloading our dataset. I will leave a link for the dataset. It will be here, okay, as part of the install file. As you can see, it's on Kaggle 5 vehicles for multi-category classification. So let's go to the website. As you can see here, this is the dataset. And if we scroll down, you can see that the dataset contains, here you can see on the right side, more than 6,800 images. And those images are divided to 5 categories. Let's open on the right side the train. As you can see, there is category of bus, car, motorcycle, train, and truck. And there is also a test subfolder and a test and a validation subfolder. So download this dataset to your local machine. I have already done it, and as you can see here, I can see all these subfolders. This is, for example, all the train buses. Very nice. And here there are motorcycle. Great. I believe that this is clear. And now we are ready to start coding of fine-tune our vision transformer model. Okay, let's start with the coding. So this script will train a vision transformer model with classifying images. So let's create a new Python script named step number 1, load data and train model. And this script will utilize the Google ViT based PET16 model from Hugging Face. So let's start with importing the necessary libraries. You can see now are the list of the relevant libraries that we will use in this script. And after that, we will use the dataset for training, validation, and test, and load it from our image folder. The most important class that we are going to load is the ViT image processor. It will help us to load the pre-trained model from Hugging Face. We will also import the early stopping, so we don't need to train it for a long time. We will look for the improvements during the training, so our training will be very short. So first of all, we are loading all the relevant Python libraries, and Next, we will specify the dataset path. As I mentioned earlier, I already download the 5 vehicle for classification dataset. I already extract the zip file and store it on my local machine, and it contains 3 subfolders, one for the train, one for the validation, and one for the test. So we will load all the data from those libraries, and basically first we will specify the dataset path. Since I'm coding with freestyle coding, probably I will have some syntax error, so please be patient. I will fix it sometimes during the coding and sometimes after I run it on the first time and discover it, and then obviously we'll fix it. So let's store the path for our data, and then also create a train directory variable, one for the train, one for the validation, and one for the test. So let's use the join function to join between the base folder and also the train, validation, and test. Let's also generate a working directory. Let's name it data_dir, and in this working directory or output directory we will store all the model results. Great. Let's name it 5 vehicle under the temp folder. And next we will load the ViT image processor for pre-processing the input images. So let's choose our model. I already explained it that we will use a pre-trained model from Hugging Face. So we don't need the Hugging Face directly in order to download anything, but just for now I will display it on my Chrome browser, so you can find it yourself as well. So let's do a simple Google search, Hugging Face, and Google, and the specific name of our pre-trained model. So as you can see, this is the model in Hugging Face. Let's just copy the link and put it here as our model ID. Now we will use the image processor class with the from pre-trained function in order to load or to download the model for our script. So it will be an on-the-fly download. It will be automatically. As you can see, I forgot to add the word path before the join. So it's it's an error. I fixed it. So let's continue. Now let's define a custom transformation function for the dataset pre-processing. Let's name the function transform, and this function will convert image to tensor using the ViT processor, and also remove the batch dimension from the data loader and return the result. So we will do this transformation for all of our images for our training. Of course, you're welcome to subscribe my channel. More videos will be uploaded soon. I have in my channel some playlists regarding object detection, image classification, image segmentation, and so you're welcome to subscribe my channel and look for those playlists as well. Next, we will load the dataset using the Torch Vision image folder and apply the transformation that we defined before. So one would be for the train, one for the validation, and one for the test data. And after that, let's double check if everything was loaded correctly. So just let's print the trained dataset, and we're expecting to see the number of images, those trained images that was loaded into the trained dataset. As you can see, more than 5,000 images in the trained dataset. Next, let's define a collate function. This will deal with the batch of images and labels correctly for the train. So this collect function will separate images and labels from the batch, and then stack images into a batch tensor and convert the labels to tensor. Great. Next, we will load accuracy evaluation metric from the Hugging Face evaluate library. So we will use the load function for that. Next, let's define another function, and the target of this function is to compute accuracy during evaluation. So this compute matrix will get predicted class labels by selecting the max index. Then it will get the ground truth labels, and after that it will calculate and return the accuracy. Great. The next phase will determine the number of classes dynamically based on our dataset. Next phase will be loading the ViT, the Vision Transformer model, with the specific number of output labels. We have to fix it. Should be ViT for image classification. As I said earlier, I'm doing freestyle coding. I probably have some errors. So now we can load the ViT model, and we will send the model ID, the one that we defined earlier from Hugging Face, and the number of classes. Now, if you have a GPU card, you should move the model to the GPU if it's available. Otherwise, you should use your CPU. Next, we will define the training arguments for the fine-tuning the model. So I will run through all these arguments, and let's run the model on 1000 epochs. I believe we can do it on less epochs. We will probably change it. And the first one would be our output directory. This is the working directory that we defined earlier. It will be, all the model checkpoints will be stored here. Next, we'll define the batch size for evaluation. And the next step will be the evaluation model at fixed interval. So this will be the strategy of the evaluation. Next is the number of epochs. Let's change it to 200. I believe we will not run 200 epochs. It will probably be less. Then we would like to save the model every 100 step and evaluate the model every 100 step. Let's define the log training progress for every step, and also the learning rate for our optimizer. And for the saving, let's keep only the last two model checkpoints, and also avoid dropping for unused columns from the dataset. We don't need to upload the model back to Hugging Face Hub. And also at last, let's load the best model based of our validation performance. After that, let's define early stopping callback to stop training if the validation accuracy does not improve, and let's decide that our patience will be 10. That means that it will stop training after 10 evaluation steps with no improvement. And also let's define the thresholds. It requires an exact improvement to continue training. Great. Now it's the training process at last. Let's define the Hugging Face trainer for training and for evaluation. So now we will send all the relevant arguments for our trainer, the model, the one that we have just downloaded from Hugging Face, all the training arguments, the data collator function, the compute metrics, the train dataset, the validation dataset. Next would be the image processor, the vision transformer image processor that we defined earlier. And at last, the callbacks, the early stopping instance that we also defined earlier. Great. Now let's train the model. So we will use the train function and everything will be stored in the train results variable. Of course, it's also the weights will be stored on our local machine, but for investigating and discovering everything, it will be stored in the train results. We would like to save the final trained model. Also, we would like to use all the log training metrics and save all the training metrics. And let's also save the trainer state for resuming training if we would like to continue from the process, from the step that we already finished. And after that, after the training, let's evaluate the model on a test dataset, a dataset that the model never saw before. And so we will run the evaluate function using our same trainer, and also use the log evaluation metrics and save the evaluation metrics. Everything will be stored in our output folder. Great. Let's fix some syntax error. It should be else. Okay, great. What else? Oh, this should be a function, train. Okay, what else? And this is return 10 source. Okay, and I forgot to add a parameter for the train batch size, not only for the evaluation batch size, for the train batch size as well. So let's run the training, and it took about 15 minutes for all the training until the early stopping pop up. So let's stop now and we will continue after the training will be finished. So after about 15 minutes, yes, only 15 minutes, the training has finished. As you can see, in our training arguments, we defined 200 epochs. However, since it's a fine-tuned and not a full trained model, the process was a little bit faster, and you can see that there is only about four and a half epochs, and the training loss is about 0.19, so it's a very good result. Also, if we go to the evaluation metrics, we can see that the accuracy is 0.8, a very good accuracy. It's more close to 0.9, and the evaluation loss is 0.3. And where is the total training time? Here it is. It's about 16 minutes. So now let's see the saved location. If you remember, we save it here under ViT_custom. So let's see our folder. As you can see here, we store it under temp 5 vehicles ViT_custom, and all the saving weights are stored here. So now let's continue to the next step, which is testing our model using the test images. So let's write a code for testing our model. So once again, let's create a new Python file. Let's name it step number 2, test the model. And as for starts, let's copy the same Python libraries that we used for the training. And next, let's define our output folder, the one that we use to store all the model and all the weights for our model. So we can just copy this. It's the same folder that we used for the training. And next, let's define the path for our test folder. And now we can load our saved model into our image processor. So please notice we are using the same function, but now we are not loading it from Hugging Face, but from our local machine. Then let's move to evaluation mode. And also, if you have a CUDA GPU card, then you should define a device variable. We will use it. It will be a faster prediction. And we are moving our model into this device. Now let's define our image processor. And the image processor will be the same from Hugging Face. So basically we can copy this command from our previous code. We should import, of course, the class, and then the argument should be the Google ViT base patch 16. Next, let's load the class names. We can load it from our test folder. It's the name of the subfolders under this test folder. And let's run this script just to figure out if everything is okay and we don't have any errors. Let's wait a few more seconds. Great, as you can see, here are all the classes name. Now let's load these 6 random images. So the first part of the code will be choosing those 6 images. So let's say first of all define a variable that contains all the test images and all the corresponding labels of these images. So we will run a for loop and get all the PNG files, JPG files, and JPEG files, and then we will also load the name of the subfolder that they will store, and this name will be our label name. So now we have all images variable that contains all the test images and all the relevant and all their labels. And since we have this all images variable, now we can run, let's extract from it 6 random images. So we will use the random.sample, and now this random image path contains those 6 random images. Let's run it. And now, as you can see, it's like a list, and each item has one image and one label. One image and one label. Great. Now we can run a loop through all these 6 images. So let's define a diagram based on PyPlot. And this diagram will be of 2 by 3 images, a total of 6. And let's run a loop, and each time we will store in the relevant placeholders in this diagram. So for each of the images we will load and pre-process the image for the prediction. So first of all we will load the image, and of course it should be an RGB images. And next we will use the image processor in order to convert the image and prepare it for prediction. And so our sample image, the one that is one of the 6 images, yes, the image will be converted to the processed sample, and this will contain the image for prediction. Then we will predict the label using our model, and the result will be stored in a variable named outputs. As you can see now, model, and we are sending the processed sample image. Now we should get the best score, the best class from this image. So we will use the argmax function. It will return the number of the image, the value of the image, the value of the class. It should be a value between 0 and 4, since we have 5 classes. And next we will convert the predicted class to the predicted label using our classes names list. And at last we will display the image in the relevant placing holders in our diagram, the PyPlot diagram. We will remove the axis. It's not a real diagram. It contains 6 images. This is the main target. And in the title of each image we will display the true label that was extracted from the name of the subfolder, and the predicted label that was generated a few lines before. Basically that's it. And after that, of course, we should show the PLT PyPlot. And I believe we are ready to run the result. This one should be subplots. Okay, it's another error. I fix it, and let's run it. So now you're seeing the first 6 random images. You can see that the true value and the predicted value are the same. Let's run it again. It will grab a new 6 images. And once again, you can see that our model doing a very great job. Thank you very much. I hope you enjoyed this tutorial. See you in my next videos. Bye bye.